Welcome to IQ Checker YouTube channel, home of science quizzes and IQ tests.
This is the part 6 of our likely questions in preparation for the Cambridge exam. So we just dive right into our first question that says, look at the information about the chemical formula of nitric acid. So we're given HNO3 there. And looking at the formula, the chemical formula of nitric acid contains one atom of hydrogen, one atom of nitrogen, and 3 atoms of oxygen. Look at the information about some other chemical formulas. Chemical formula of sodium oxide contains 2 atoms of sodium and 1 atom of oxygen. Potassium sulfate contains 2 atoms of potassium, 1 atom of sulfur, and 4 atoms of oxygen. Write down the chemical formula of sodium oxide and potassium sulfate. Now back to the reference formula that we're given the formula of nitric acid, which is HNO3. Now using the information, it says nitric acid contains 1 atom of hydrogen, 1 atom of hydrogen. So when you are having 1 atom, you just write the chemical symbol of that element. So no need for subscript like this 3 there. No need of you writing 1, just write the symbol. So that's why you have H given there for hydrogen. 1 atom of hydrogen, 1 atom of nitrogen, just see the symbol N for nitrogen. So if it is 1 atom, you just write only the symbol. But when you now begin to have more than 1 atoms, 2 atoms, 3 atoms, 4 atoms, then you need to introduce your subscript immediately after the chemical symbol. All right. So in this case now, 1 atom of nitrogen, you still have what? 1 atom of nitrogen, just the symbol. All right. But when we now have 3 atoms of oxygen, we have the symbol for oxygen, and we have a subscript of 3. Just write immediately after the symbol. So when you have more than 1 atom, like in the case of oxygen here, then you have that number written as a subscript. So based on this information now, we're going to write chemical symbol for sodium oxide. And with the information we have, it says 2 atoms of sodium. And now you should know the chemical symbol of your first 20 elements. And if at all you don't remember, you have your periodic table at the back page of your question paper. So not a big deal. Now the symbol for sodium is known to be Na. And it says 2 atoms. So you're going to be having your subscript immediately after the symbol. Then 1 atom of oxygen, just the symbol for oxygen, no need of writing 1. And with this, you've written the chemical symbol for sodium oxide. So with this, we put our symbol there, Na2O, that's the symbol for sodium oxide. Then we now write for potassium sulfate. So based on this, you should be able to do that now. It contains 2 atoms of potassium. Whenever you have more than 1 atom, definitely you'll be introducing the subscript there immediately after the chemical symbol. So the symbol for potassium is uppercase letter K, and then 2 atoms. So we're going to be having a subscript of 2. Then it says 1 atom of sulfur. An atom of sulfur, just like the symbol for some sulfur, which is S. Then 4 atoms of oxygen. So you'll be having the symbol for oxygen, and then the 4 will be a subscript, 4 atoms of oxygen. So with this, everything for potassium sulfate, and we fill our space provided as K2SO4. That is the symbol for potassium sulfate. So with this, now we are good with this. We can proceed to the next one. And it says, Mike investigates the minerals that plants need to maintain healthy growth. The diagram shows the equipment marked here. So the diagram here, you can see the plant growing. We measure the height to which the plant has grown. Then the container there, you have liquid with nutrients, some without nutrients and all of that. So look at the plant Mike uses. So here are the plants. The first thing he did, take 5 identical plants, then put each plant into 7 cm cube of 5 different liquids labeled A to E. Right? And each liquid A to E contains different types of nutrients. Then the last step, let the plants grow for 5 weeks. So at the start of the investigation, each plant has a height of 3 centimeters and has 4 leaves. That's at the start. The height is 3 centimeters and has 4 leaves. The question now is, suggest to all the variables that Mike controls in this investigation. Control variables, something that Mike should keep the same across all the plants labeled A to E. Plant A must have it, plus plant B must have it. It should be the same across, but it should be controlled. And what are the things, the variables? We have the likes of the same temperature, all of them must be exposed to the same temperature. Then the plants must be of the same age because differences in age can affect the experiment. Then all of them must be exposed to same light intensity. The amount of sunlight or whichever light is provided for the plant must be the same across board. So they must be exposed to the same temperature. The plants must be of the same age and they must be exposed to same light intensity. All these are what we call the control variables. Now, look at this next question that follows. It now says, write down the independent variable in this investigation. The independent variable on which the dependent variable depends that affects the growth rate. So what will be that independent variable here now? It is the type of nutrients in the liquid. Because if you look at this very step here, all right, it says put this plant into a 7 centimeter cube of 5 different liquids. And these 5 different liquids contain different types of nutrients. Because that's what will now affect the rate at which this plant grows, whether they are growing well, using better leaves and all of that. So the experiment, the plant itself depend on this independent variable. The type of nutrients in the liquid serves as the independent variable. So this will now take us to our next question that says, a table shows the observations Mike make after 5 weeks. So after the experiment, these were the observations. You see the liquid labeled A to E, the height of the plant in centimeters. So after measurement, the number of leaves also observed, then the appearance of the leaves, the colors of the leaves were also observed. So now one of the liquids is pure water. Pure water does not contain any nutrients. Mike writes this conclusion. He says liquid E is pure water. Do the observations support this conclusion? So we have to answer yes or no and circle that. He said liquid E is pure water. Now let's look at the table. Is liquid E truly pure water? Look at liquid E down there. This is liquid E here. And based on this observation, the height of the plant is 3.5 centimeters. Number of leaves, 2. Appearance of leaves, yellow. So is liquid E water? From this indication, there is no better growth experience because we started with what? 3 centimeters. The number of leaves dropped from 4 to 2. So it withered. So no growth is experienced. So, and the remaining leaves that were left after the 2 leaves were dropped out of 4, and the 2 that were left appears to be yellow. So it means that there is no growth at all, no nutrient present, and is likely to be true. So because of that, we can say that his conclusion actually makes sense. And that is yes, the liquid E is pure water because it does not support growth of the plant. It now says that explain your answer, that we can say that the plant has the least growth, the plant has less leaves, and those were the things we observed in the table as well. So the plant has the least growth. Among all of them, we can take a look at this again. See the growth. A is having 4.5, B is 5.0, C is 6.0, D is 6.0, and E 3.5, which is the least amount of growth observed in the plants. And then for the number of leaves too, it is the one that has the least number, 2. And we started with 4. So 2 has withered off. So definitely liquid E, according to Mike, is pure water. Then circle which liquid contains the best nutrients for plant growth. So which of the liquid contains the best nutrients for plant growth? So look at the table now, observe closely to see which of them is the best. First of all, looking at the plant height, the height of plant, you can see plant C is having 6 centimeters, 5 leaves, but the leaves are what? Yellow. But look at D, 6 centimeters in height, number of leaves has increased to 5, and the plant is green to tell you that the plant is still healthy. Number of leaves has increased in height, but for this one made it not healthy. So our best shot here now is D. So the best liquid for this plant growth that produce the best height, increase the number of leaves, and the leaves still remain very healthy and green is D. So we'll now go back to our options and cycle D, and D is the best liquid. Liquid D contains the best nutrients for plant growth. All right, so with that, we're gonna stop here. So be on the lookout for the next one. Thank you.